Welcome back. This is lesson 8.3, Journal Modeling Addition Equations. I will be able to model addition equations using Algebra Tiles. I will be able to make an accurate representation of each equation and show my work mathematically. Vocabulary for this lesson, you're going to need your vocabulary page, which is for chapter 8, page 108. We're going to talk about equation, solution, and inverse operations. So, equation, we talked about already, is when we have a mathematical statement that two expressions are equal to each other. A solution is a value that makes an equation true for a variable. Okay, inverse operations is what we're going to add. So, inverse operation is the opposite operation that can undo the other operation. So, examples of inverse operations: add and subtract. Those are inverse of each other. If I want to undo adding, I can subtract. If I want to undo subtracting, I can add it back. Okay, the other ones that we're going to work with are multiply and divide. Multiplying undoes dividing, and dividing undoes multiplication. They're related to each other. Alright, so with that, let's go back here. When you are modeling equations, see this teeter-totter scale down here? So I want you to think of the equal sign as the fulcrum. So this is a fulcrum. So right here, it's balanced. If it's equal, this side needs to be exactly the same as this side. So think of it as a fulcrum of a balanced scale. What is on one side must balance exactly what is on the other side to keep that true. So looking at this, I want you to remember, we've done these algebra tiles before, but just a little reminder. A long rectangle is going to represent a variable. So x or r or whatever we use, that's going to be our variable. And then we use little squares to represent 1. Alright, so on this side of the balance scale, I have x plus 7. So we're going to draw 1x. And then we're going to add 7 of these squares onto this side. So 1, 2, 3, 4, 5, 6, 7. Okay, the way this sits, this side would be heavier because there's nothing on this side. But on this side, we're going to draw 12. So we're going to draw 12 of those little squares. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So on this side, we have x plus 7. On this side, we have 12. And since they are equal, we know that they weigh the same amount. What we are trying to do, though, is figure out what the x is worth. We know that x and 7 is equal to 12, but we want just x. So if I want to get x by itself, what am I going to do here? I'm going to take off 1, 2, 3, 4, 5, 6, 7 of these little ones. So what I am doing is I'm minusing 7. Now over here on MathWork, you see how I have my equation written again? Okay, this little dotted line represents each side of the equal sign. What we just did is we subtracted 7 ones. I want you to show that over here. We subtracted 7 ones. Now, if I only took them off that side, then this side's going to be heavier and it's going to go crash to the bottom, right? So to keep it balanced, I have to do the same thing to the other side. So I'm going to take off 1, 2, 3, 4, 5, 6, 7 of these over here. So look over here, I'm showing my math work here as well. I took off 7. So this is what is called balancing equations. What you do to one side, you have to do to the other. Now here, if I had 7 squares and I took off 7 squares, how many squares are left on this side? Well, I'm left with x. I didn't take x off. But now I have 0 squares. Understand how I got that? If I added 7 and then I minus 7 away, I'm left with no squares. So if that's the case, I can say this is the same as just x. Agreed? So, add 7 minus 7 cancels out and it's like nothing ever happened. But to keep that balanced, on this side, we took off 7 as well. So what is 12 minus 7? Well, we are left with 5 squares on this side now. So, from my picture, do you see how 1x is equal to 5 squares? What we're saying is that is our solution. Now we always have to check our work. If we think x is worth 5, now what we're going to do is we're going to plug that back in to the original equation. So if x is worth 5, I'm going to check it and see if it really is a solution. So I put in 5. So 5 plus 7 equals 12. 5 plus 7 is 12. 12 is the same as what I get on this other side. That tells us we did our work right. Now, I know that your brain is screaming at you, no duh, I could do this in first grade. I'm picking easy numbers so it's easy to model and so that you understand the process. This isn't a hard process, but when you start putting in decimals and fractions and larger numbers, it's not so obvious. So if you can get these skills with these simple ones that your brain easily understands, then it makes a big difference for later. Alright, let's try modeling this one. So we have 5 plus r, so that means 5 little squares. 1, 2, 3, 4, 5 plus r. So on this side of the equation, this is what we have. Over here we have 9, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, if I want r all by itself, that means I need to get rid of these 5 blocks. So, gone. 1, 2, 3, 4, 5. But if I do it to one side, I have to do it to the other to keep it balanced. So take 5 off of this side. Now show your work over here. What did you do? You took 5 blocks away. So if I took 5 blocks away from the 5 blocks that are there, I'm left with 0 of the little blocks, but I still have 1 r there. Now over here we took away 5 blocks. How many are you left with on this side? 9 subtract 5 equals 4. And you can see that here from the 4 blocks that are remaining. So what we're saying, 0 plus r is the same as just r. So r equals 4. Okay, let's check by plugging that in and seeing if that's a true statement. 5 plus 4 equals 9. We just replaced r with 4. Now 5 plus 4 gives me 9, and 9 equals 9. So yes, that is a true statement. That means r is worth 4 blocks. Okay, let's try this next one. 14 equals f plus 8. So that means I'm going to do 14 blocks over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. On this side, f, I'm going to turn it this way so it doesn't take up so much space. So f plus 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, my model matches my equation. Now the whole idea is to get f by itself. So I got to get rid of all this. So I'm going to take off 1, 2, 3, 4, 5, 6, 7, 8. Minus 8 leaves me with 0 blocks. 0 ones, but 1 f. Have to take off 8 on this side to keep it balanced. 1, 2, 3, 4, 5, 6, 7, 8. So subtract 8 from this side as well. Keep it balanced. 14 subtract 8 is 6. I can see here I have 1, 2, 3, 4, 5, 6 blocks. So f plus 0 is the same as just f, so I am saying that f is worth 6. Plug it in and check it. So 14, see how I take the exact same equation, except I'm replacing f with 6. So 6 plus 8. 6 plus 8 is 14, and 14 is equal to 14. That tells me that f equals 6 is a solution to this equation. Okay, last one we're going to model. 11 plus equals 3 plus h. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On this side, 3, 1, 2, 3 plus h. Okay, we have our model. Now to get h by itself, that's what I want, 1h. What is h worth? I'm going to take off 3 of these blocks. That means I'm going to subtract 3. Notice how it's just the opposite of what was happening. I was adding 3, so now I'm minusing it, using inverse operation. 3 minus 3 gives me 0, so now I have 0 plus h. Minus 3 from this side, 1, 2, 3. Now it's balanced. That's going to leave me with 8. 1, 2, 3, 4, 5, 6, 7, 8. So h is equal to 8. Let's prove it by plugging it back in. 11 equals 3 plus replacing h with 8. 3 plus 8 is 11. That tells me I am correct. Alright, rate yourself on this concept. 0, 1, 2, 3, or 4. Take a picture and turn it in on your passport on Google Classroom.